this tutorial, we are going to study working of a D flip-flop. In the previous tutorial, we have studied about the SR flip-flop. In the SR flip-flop, we have seen that if S is equal to 0, R is equal to 0, then there is no change in the output. Then if S is equal to 0, R is equal to 1, then output is 0. Then if S is 1 and R is 0, then output is 1. And then for 1, 1 means S is 1 and R is 1, the output goes in not allowed state. And that is a forbidden state in the SR flip-flop. So in the D flip-flop, what is done? You can see in this block diagram that S and R are combined together, but after inversion, means we are connecting this S as the input D, and then S is inverted and it is connected to R. So it is going to avoid that last forbidden state because S and R are not going to be equal. If S is 0, then R will be 1, and if S is 1, R will be 0. Look at the logic diagram for D flip-flop. This is the basic SR flip-flop, the gated SR flip-flop. Then this is the clock pulse. So you just have to connect an inverter between S and R. The input S is connected as a input D, and then it is inverted and it is given to R. Now in the truth table we have only two conditions, that is D is 0 and D is 1. And one more input condition we have to check, that if clock is 0. And you already know that if the clock is 0, then the output of the flip-flop is not going to change. So the same will be the case for D flip-flop as well, that if clock is 0 and whatever may be the condition for D, that it may be 0 or 1, the output will remain in the same state. So it is QN. We can say there is no change in the output, or we can say it is in the previous state. Then we have to check that if the clock pulse is 1 and D is 0. If D is 0, then S will be 0 and R will be 1, because this is inverted, and then at the output of inverter you will get 1. So as we have checked for SR flip-flop, if S is 0 and R is 1, then in that case you get the output Q is equal to 0. So here the output will be 0, and this is called as the reset condition. And then we have to check for one more input condition, that if D is 1. If D is equal to 1, it means that S is 1, then it is inverted and given to R, so it is 0. So in SR flip-flop, we have seen that if S is 1 and R is 0, then your output is in the set condition, means Q is 1 and Q bar is 0. So here in the observation table, Q is 1 and that is called as a set condition. In this observation table, it can be seen that the output follows the input. If D is 0, Q is also 0. If D is 1, Q is also 1. Means whatever is applied at the input, the same appears at the output. If you apply D is equal to 0, then Q will be equal to 0. If you apply D is equal to 1, then Q will be equal to 1. That is the simple working of a D flip-flop. And due to this property of a D flip-flop, these flip-flops are used for the construction of shift registers, where the inputs and outputs are same, but it is used for the temporary storage of a digital data. That's it for this tutorial. Thank you.